Cool. Hey everyone. It's been a while since I streamed. At work, my name's Aaron, and I'm a data scientist who is now working on a pretty interesting natural language processing project. So I figured I would just start streaming it. Luckily, this is public data, and while I'm using work equipment, I can't think of a reason why this would be a problem because it is totally public. I put the link to the data in the chat, so if you want to experiment with yourself, you can. You will need to download it yourself. It is a zip file. It's like 500 megs. Um, I compiled everything into one like really big CSV. It's like 1.8 gigabytes, just because it was the easiest thing to do to handle all the stuff locally. Um, what we're gonna do, because it is a data frame that has a bunch of free text in it, luckily redacted, so it should be pretty clean. Um, we're gonna bring it into Jupyter and just mess around with it and see what we can get. This is a pretty walkthrough-y process of natural language processing for this, because I literally just got this data like yesterday. So yeah, let's get started. I will switch into, here we go, cool. All right, so I already started like the beginning of a notebook. I removed my work email for this, but basically I've got Jupyter Lab running, and I am trying to just do some EDA. You can see here I like try to do this, like lay everything out, have the resources, make everything kind of clear as I'm working, and probably something that I will actually show for the stream, but I normally won't put in here. I'm actually going to put the packages like right into this thing. So you'll probably need a bunch. Like for NLP, I'm using Spacey, and I'm going to use Jensen for topic modeling just because it seemed like that was the thing people do. And I have NLTK installed. I can't really decide whether I want to use NLTK or Spacey for processing the text, and also whether or not Jensen or I think NLTK might be able to do it, but definitely scikit-learn. Like I'm pretty sure I'm gonna have to use it later, but I haven't decided which one to use yet. So I figured I'd just have them both. And I can even just compare the models later. So if I do this, it should display everything that's in there. Yeah. If you don't want to, actually pip is kind of ugly. So let's turn this into a line, make it a little bit cleaner. So I'm going to do conda env list, and I personally prefer conda because it's supposed to resolve. That's not what I wanted. Conda env info. That's not it. Okay. I think it's just kind of list actually. I almost never do these. I just export it into an environment.yaml. There we go. Cool. So like I usually do, I make a separate virtual environment for every project I'm working on, and that didn't change with this. So I made a virtual environment to handle, these are form 2567, and I just basically cloned the base repo for Anaconda, and then I added things that were needed. So you can see here I added stuff from Conda Forge or Python, or sorry, pip. One of these things may not be working, but we're not using that right now anyway, so that's fine. Also, if I use that one, I will definitely get in trouble because it is non-redacted, very unpublic data. So yeah, big things you'll need for this are, you're gonna have to, honestly, I think the easiest thing is just use Anaconda, or get Anaconda working, and then you want to add Jensen and Spacey. Yeah. Let me hold on a second. Yeah, and if you see anything, like, feel free to chat me. That is totally fine. Oops. hold on a second. Man, Windows, why are you doing, there we go. Okay. Windows 10 is doing that thing where like when you copy paste, it like preserves some additional context, and sometimes you just want the link to go up. You don't want the preview to go up. So yeah, these are the packages we've got. So things you'll need. I'll write this in chat. Things you'll, or I guess things I recommend. Things I recommend. Anaconda. Then install Gensim and Spacey, because that's the stuff we're using right now. And neither of those two is included by default in Anaconda. So yeah, for external resources, usually when I do notebooks, I kind of like make changes, write stuff, and then when it starts getting messy, I'll try to refactor so that it's a little bit neater. And one of the things I noticed right away was I needed to do regex. So there's a flag, which you'll see, where things basically have a bunch of like pretty ugly intro text, just denoting that this stuff is redacted. So I had to make a regex expression just to get rid of that thing. So yeah, we've got regex, NLTK, Spacey for tokenization, and then Gensim for topic modeling. And some of the stuff for data, it's already in the chat, but it's also in this link here, which is hidden. And then I will actually make this bigger because it's a little hard to read, I'm realizing. Zoom in. Cool. Yeah. That should be better. I'll zoom in a little bit more. I'm aware I can just do like Command Shift plus, but wanted to show it more explicitly on the stream. So yeah, I'm zooming in, and then now here's like external resources for the code. And then I'm kind of referencing this building a topic modeling pipeline with Spacey and Gensim. So I've got this page open here. It is on Medium and it's from Towards Data Science. So like you're going to hit this, like you only have a certain number of things to read per month. But I thought it was really helpful because Spacey's documentation is really nice, but the thing with Spacey is like it's kind of like a processing library. So it basically will help you make a bunch of these tokens and stuff and assign all the tags, which is great. It's like super great. But to use it later, you have to like kind of plug it into something else. And Gensim was supposed to be the one that's like very good at doing topic modeling. Yeah, so I'm going to do it with this. Later on, I'll probably try to just throw it into scikit-learn because that will make some vectors and maybe I can do topic modeling through that instead of with Gensim. But yeah, right now, some of the things that we asked for at work are, you know what, why don't we just look at the data? That's more interesting, right? And then that will help explain some of the things I'm about to describe. So yeah, what I'm going to do is I'm going to restart the kernel and clear all the outputs because you should probably see what the notebook looks like when it's clean. Okay, here we go. So I'm going to comment this out because it is a mess. And I don't know if it's entirely necessary to see this for you. So yeah. Basically, we've got the virtual environment working, and we're going to start shift entering through all this stuff. So we're going to import a bunch of the stuff that is needed to get this to work. Actually, in hindsight, I don't need to import NLTK right now, but that's okay. I wrote this helper function to basically just remove a bunch of the empties based off of something I saw on Stack Exchange. This comes in later. Excuse me. Oh boy. This will come in later because, or come in handy later because when some of these things get split, it is actually really like not great when it gets split, I sometimes ended up with this empty text. So I just wanted something that's like, just get rid of these. So yeah, this will be thrown into the pipeline. Same with this lemmatizer, trying to get the lemmas from each token that's in the each sentence or document. And then also removing the stop words and then adding these to the pipeline once we actually put this into Spacey. So yes, now that these functions are defined, we actually have to commit them. And like I said earlier, I took all of the Excel sheets that are in that like zip file that's on the website that's in chat, and I very annoyingly took all of them and just put them into one CSV and have put them on my local computer. I can't share that anywhere, not because it's not public, but because it's 1.8 gigs, and I don't have reliable way to share that. I know I can get free Amazon S3. Did not feel like doing that. So yeah, this is just stored locally for me. This is honestly a stopgap. So the hope is that when I get private database access, which I won't be able to stream at all, I don't need to do this like through this with the CSV thing. So yeah, I'm going to treat everything as strings because as you'll see when the data frame opens, there were things that I discovered that I need to actually have Python parse as a string. Otherwise, we're going to have problems later. So this does take a little while. Yeah, there we go. So the data frame or the CSV as imported into a data frame has a bunch of stuff in it. So there are basically the facility name, facility ID. I believe these are all nursing homes because it's all from the nursing home data sets. The address of the place, zip code where the place is at, and then an inspection date. So when a surveyor went in and looked at the facility. There's also deficiency tag. Again, these are all public, so you can find all this stuff online. You can even, if you just Google like how Form 2567 works, like you'll find instructions on how these are all conducted. And then there's a scale of severity for each case, and then complaint standard, infection control tag, event ID, and then the thing that we're actually doing the NLP on is inspection text. So as you can see, there is a lot. There are 368,000 records in here, and these have all been processed and then made public. And you can see here in this inspection text, which we're going to zoom in on with the first one as an example, note in terms, notes. Actually, it's just, here we can see like there's some intro stuff. But if we grab the first one, we can see like note terms and brackets have been edited to protect confidentiality. And then you can see here that there's a like break character. This is something I don't know where this is coming from. Since I don't have access to the raw data set yet, I don't understand why this is here. It reminds me of like HTML or XML, and I don't get why someone would write that. So I don't know if this has been parsed and then this like line break just gets added in. But obviously, we don't care about this part or this part, and it looks like almost every entry here is going to have some sort of declarative statement saying that private information has been removed, or it's just going to start with a line break, and I don't know why I would do that. However, we definitely need to get rid of these things, right? Because this doesn't help, and then this would keep showing up, and it just kind of like this could be a problem later, where if someone actually is violating private information at the nursing home, if this shows up in every single tag, then it like reduces the weight or the importance of this phrase. So we need to put something in here to remove everything between these stars or these asterisks, and we also need to put something that removes all of these line breaks because they're just like really distracting. So the thing I wrote was a regular expression. I am not good at regex. What I actually did was, if we go back up, this thing, regex 101, is great. All I did was I took basically the value of this text, and then I went to this site, regex 101. We didn't even open it. Um, and what you can do is, and let's copy the text over. We'll look at this again. So we put this test string in here, and then like we can just put stuff in here that helps us figure out how to get rid of it. So in this case, like when I do this gobbledygook, it highlights the thing it's actually found, right? Super useful. I am like, I don't recognize or remember these things that like actually do regex, so having this tool is great. Highly recommend. So yeah, if you see this stuff, like if you ever run into a thing where you think you might need regex, like just grab a tool. Like it's there to help you. And honestly, like I wouldn't have known what these things mean, right? Like I know now that like putting a literal backspace means that like don't treat this as a special thing, like treat it as a character, and then again treat it as a character. I think this is like anything inside these brackets, just highlight that. But like stuff I don't remember. Oh, actually, yeah, look at this. If you look over here, it does actually explain like what all these things mean, right? So it's match the asterisk character literally, and then match any character, and then match previous token between 0 and unlimited times. So I think if you replace this with like 3, it will match it only 3 times. And then match the character, the closing. In Chemi classes, we call this the ket. I don't think that's right, but like we had a thing that was like bra ket notation. It was kind of stupid, but like that's all I remember it for is a closing ket. So yeah, this means that like when I add this in here into the stir.replace, it is going to find it and just replace it with this, which is nothing. So when I do this, I make a separate column for it because I don't want to modify it in place on all this data just in case something goes wrong. You can see that like it cut out this like note type of introduction from everything. So that's great. That worked fine. However, we also need to replace, it didn't fix this issue where anything that starts with a line break for whatever reason, that's still there. So we have to do that again. So what I'm going to do is I'm going to replace these brackets, sorry, not brackets, the line break substring with just an empty string. So when we do this, it'll take a little while because it has to process 3/8 of a million records, and it just goes through here. And look, we've added a new column to the data set or data frame, and it has all this extra stuff in it. Oh, hey. Oh, wait, no, I put that in chat. Let me pop in for a second. Yeah. So now that we've got data frame with this like flat data, one of the things I couldn't decide, I guess to back up a little bit, this inspection text is it's complicated, right? So it's all free text, but what makes it potentially more complicated is that some of these line break characters, for example, if you read this one, it kind of seems like they're actually lists inside. So this is supposed to represent one inspection, and then the surveyor saw a bunch of things that happened, right? So if they're supposed to be several instances that get put into one report, then it's kind of important to keep that context of like these are all one thing. So I couldn't decide whether or not to keep this as one massive string or to make each of these inspections basically a list of lists so a list of lists where inside those lists is several strings based off of where these brackets are. So to be honest, I couldn't decide which of those things was the right thing to do. So I decided to just make a separate one, separate column that basically does the filtering as above. So it replaces the intro with empty string, but then it also applies that remove empties helper function that I wrote before. So it will go through and find all these line break characters and then basically break. Okay, so sorry. What it does is that it goes through, it replaces each of these long strings with a sorry, it takes the long string, splits it wherever this like line break character is, so that the long strings become elements inside of a list where new elements in the list are caused by this line break. And then when it does that, it will then send this through this remove empties function that I wrote, and it will find all those empty, like it'll be like empty string comma entry, and then just remove them because they're not needed. And this did come up, especially some of these reports, like actually this one here, 368.169, started with this line break, and then this one, the first one, ends with this line break. When I ran this before, putting through the filter out the empties or the remove empties, it would keep for 368.169, it would keep this as an empty element leading, and then it would also keep this as an empty element on the final. So on some of these things, I ended up with like, they would start and end with an empty string, and that's not helpful. So that was why I ended up having this remove empties in here. So we're going to process this, and this might take a little bit. I'm going to grab some water. Cool, it is done. And now look, we have got lists inside each row for this column, and then when we look at the overall data set, we can see that this was the untouched text. This is the flat text that just removes the intros and line breaks, and then this is the list of lists. This is the column where each row has a list of strings. So if we go back and see, what was the problematic one? Well, this one, 368.169, started with a line break, ends with a line break. Now that we can see, and we can look in and say, oh, cool. So it actually did split. So there's the first element here, and then second and third, et cetera, et cetera. So now that we've got these, there's several things that, we kind of want to check out. So the inspection date, when this was read as a data frame from CSV, I made this timestamps so they get handled correctly. Everything else in here is a string. There's also this alphanumeric deficiency tag, and then we have a letter indicator for scope severity. I think this is bad code because I think it will possibly crash this. No. Okay, cool. Yeah, it's not great code. So for the inspection date, like we can see that there's actually of these 3/8 of a million records, there's basically like 5 years of data. And then most common one seems to be, for some strange reason, October 18th, 2018. It looks like there's like 1,200, 1,300 inspections on that day, which is odd. And then the earliest entry is January 1st, 2015, and the most recent entry is April 28th of this year, 2021. So ranging, 6 years. In deficiency tag, there's 368, with the top one being, this 0880. And there's 20, oh wow, there's 25,000 of those. So somewhere we have got something that explains what these tags are. I learned what they were at work, and then I honestly lost the documentation that fully explains these, so I'm gonna have to go find these. Uh, because like obviously like this doesn't really mean anything unless you actually have memorized the whole dictionary um, of our tags. And similarly, the scope severity, there's 11 of them, most frequent being D. Um, and I believe we've got a description somewhere that says what these are. The things I remember most are, I think they go all the way up to L, and I think the last three are like really, really bad. So those are the things that I like remember most, and like what I would like to see is like, you know, this deficiency tag. Um, what do we have in terms of like a histogram? Like, well, we have the most common things, and like obviously we have got a bunch of these, but how many of? Oh yeah, because we have so many tags. Okay, so this is not all that helpful, right? Because there's so many tags, it's actually really hard to read. But if we do like value counts, we can see that we've got a bunch with like this many, and then we've got a lot with just one. Um, if we look at the scope severity, this should be more helpful because there's only 11 of them. So we can see like, yeah, like I think it's, uh, yeah. So I think J, K, and L, maybe I, J, K, L, those are the ones that are like super, super bad. So obviously it's better if we don't have a lot of those. So I got to reformat this plot, but it'd be better if like these letters are in the middle of the bars. But it looks like D is the most common, and then you know, it's going down. If we look, there are obviously not just one for each case, so that's a little concerning. And if J, K, and L are the ones that are really bad, then we've got kind of a problem, right? Because like there's more L's, more of these severe ones than there are in less severe ones. Oh man. um, so actually, I'm gonna take. So this is what I was working on. This is honestly, this is actually crashing in my kernel for a little while. So it's kind of interesting. We're now like doing totally new exploration. I'm gonna take all of the text and just put it into one big document. So if we see total text, let's just print like the first two because it's a lot of text. Like we have all of this. The first report is this one, and the second report is this like way longer one. So we know that the length that I don't know why I wrote this. We know that the length of the total text is going to be this like 3/8 of a million. And what we want to do is basically try to just split these and remove any stop words. So for stop words, I'm using the default ones that come with spacey. So that's why this is referenced in here like this. It's actually way up here in the import. I said, okay, we'll just, you know, from spacey .lang.n stop words, import stop words. So this function will go ahead and basically just say, okay, take the text, lowercase everything, and then split based off of white space, and only keep the word in the text if the word is not a stop word. And then this is oh, interesting. This is I'm having a little bit of a visceral reaction to this because this is code from Gensim. And I don't think I like how this is formatted, but this is a double list comprehension. So what we're doing is like for word and word inside text.lower.split, if word is not in stop words, you know, put the word in this list and then get your text here for each text in total texts, right? So we'll walk through. We start with the outer loop. We start with total text. We will go to the first document in total text and then parse all the words here. And as long as, and parse all the words there, take that word, lowercase it, and then split on all the white space into separate words, and only keep those words if they are not in stop words. So now we're doing, this is also from GenSim, create a default dict, and then for each text in that, we're basically going to see, okay, what is the frequency of each token, or where token is at the word in each new new list inside texts. And then we're going to actually go ahead and do the tokenization. So we're going to run that. And this will take a while because it has to process all of these words and then see if they're in stop words. So because I'm kind of like working through, I haven't done a lot of optimization on the code, just refactoring stuff to make it a little bit neater. And this is probably like version 4 or 5 of this notebook, because I just wanted to see what was happening and I wanted to test all that fancy regex. Yeah. So after this runs, we're going to see if this kind of like worked okay. Just do simple things just to test if everything is the code like actually processing all of the data. But this part does take a while, unfortunately. After this, we are going to want to, the goal is to basically put this into a latent, yeah, there we go, latent Dirichlet allocation. And the reason why we're trying to do topic modeling is these deficiency tags, they're all supposed to be related to some sort of topic. And one of the questions we actually had was, when a surveyor writes a bunch of stuff, they actually may run into an issue where they don't know what tag or code to file under. So we want to see if maybe there's ways to like link some of these different inspection reports with topics, just to see if like, hey, do these line up with anything, or are we missing anything, and like should we be aware of that? And then later on, I also want to process all of these individualized tokens into bigrams and maybe trigrams. It's gonna be hard. There's so many words, right? Like, probably want to do some more advanced things than just individual word tokens. But I also want to see if the severity that this surveyor has used, see how, I guess, accurate it is. It's kind of odd. This scope severity is very subjective. So I want to see if like, hey, things that are like marked JKL, are we missing things that were, say, maybe like a F or a G that should have been ranked worse? So for that, I'll probably do some sort of maybe a logistic regression, just to get the category. I can see here like there's a little bit of a problem already because it's the data's like really imbalanced, which is nice to know that like some of the more severe things aren't more common, but also it could make predicting a little difficult. Like if we do let me get a calculator here. So we just do 224,570 divided by, what was it, 375,000. So if we just predicted D for everything, we'd be right like 60% of the time. So like that's a problem. Yeah. Okay. So it's still trying to make the tokens for everything. And after this, the plans are to figure out how many reports there are to make sure it matches up with what's in the data frame already. And then we want to see like the average number of words in each report, as you can see here in the code, and then try to find the longest and the shortest ones. I think it'd be really interesting. Like, I just want to see like, are they around the same size? Eventually, I had this thought before I went streaming. I would like to just find which reports are the longest and which are the shortest. Uh, but we'll just do that after. Yeah. So I'm pretty excited. I think this is a really cool project because it's actually NLP data, and I can actually have something fun out of this. Um, Sometimes it seems like with data science, like not everything's like working with whatever model, and you're just trying to figure out how to help people out. And before this, I was mostly doing um, a lot of Excel work, honestly. So this is more in line with like what I was hoping to do, which is get data, play with it, get something meaningful. So yeah, uh, we're just gonna hang out for a little bit and hope this works okay. um, Trying to think of what other things we could get out of this. Uh, Hopefully, I'll be able to get database access and be able to process these things. Actually, with the redacted information, some of these things like the doctor's diagnoses, like those could actually be like uh, really helpful, right? Like if someplace like maybe the doctor prescribes something and then that gets removed from the record, like, well, why did they prescribe something? What if we run the danger of like doctors are prescribing things that like opioids that maybe they shouldn't be prescribing, or maybe they've been giving too many? um, yeah, so I don't know, this just seems really cool. This is like an open-ended project in all the right ways. Yeah. Man, who would have thought that processing all of these records would take this long? I think some of the work related, some of the big things that we're trying to figure out now is obviously if this is how long it takes and it's this difficult to keep processing this locally on my work laptop, we're gonna need something that has more oomph or won't slow me down so much. Um, Earlier, and you can see this already, notice like I'm only processing the first two elements, 0, 1, um, in text to tokenize, because when I tried to do this for the entire thing, it crashed my kernel. And it is not the first time that this data set has crashed my kernel. I stupidly kind of wanted to see what the individual tokens looked like, and I went, yeah, just print me the tokens. And obviously could not handle displaying like, what was it, 3/8 of a million records with like, I don't know how long did I say it was? Oh, we haven't gotten there yet. Like hundreds of words each. So it was just like printing, 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 and then crash, kernel unresponsive. So yeah. But yeah. For those who don't know, as this still runs, I am currently on the West Coast, so I'm in California, and my employer is in the East Coast. So I am way beyond my normal work hours right now, but I just thought this like data was so cool. I just wanted to keep doing it. Really excited to like try to get something out of this. I don't have work pressure to do it. Well, not really, but like I just think it's cool. So I just wanted to see how it could help. Um, yeah. And pros and cons of that. Generally, if I don't stream work stuff, or if I just want to work normal hours, I'm done by like 3. But unfortunately, I did also start my day today like 6:45, and that's generally when I start. So my caffeine honestly is wearing out a little, but I'm trying to do my best to try to keep this going. Um, I think maybe my computer is also needing like a boost of caffeine, because it I don't remember it taking this long before to actually try to tokenize everything. And honestly, it's not even tokenizing right now, right? Like it's just trying to make these new uh, lists of substrings. Um, yeah. Um, I don't know how are y'all feeling? Love to hear what y'all are up to in chat. Um, And if you have any questions, or if you do have NLP experience and want to share it, like I'd love to hear. I think NLP is such a cool collection of problems to work on. Or if you are seeing some movie, I really want to see Fast Nine, which is very silly, but I kind of love the Fast and Furious franchise. Maybe not 8. That one kind of sucked. But most of the other ones have been pretty great. So I want to see how they bend physics to do their will in Fast 9. So we can see that this is finished processing. So now we can go calculate, 368, 171. That matches with the size of our data frame, I believe. 368, yep, 171. We can see that the average amount of words in each report, based off of, I took the lengths of each individual report in the list of the whole corpora, and then just divided by, sum up all the numbers and then divide. So it says they're like 435 words each. And the longest one is 3,747. The shortest one is 3 words. This is wild to me. I don't know how you would do that. How do you submit a report that's only 3 words, right? Like, let me see. Is there a way to actually figure out? So we need to find... we're going to do this, Python find where equal to find where length equals value. Cool. Okay. Python find where length equals value. Man, I don't want to have to open NumPy. Okay, that looks like it's trying to find... Maybe what I can do is shortest equals, we'll do another list comprehension for text, and where is it? Text to tokenize. So we'll say text, if len text equals 3. Deficiency text available. Cool. All right. So, this is going to be a problem. So now I am brainstorming this, and I think this means that the actual report is somewhere else whenever this happens. So that is really interesting. And I wonder if accessing the raw database is going to fix this issue. So there are 314 reports where the text is actually deficiency text available. Or at least like maybe missing some stop words. That is surprising. Okay. So I guess similarly, we can do say longest if len text equals max. What did it call it? Lengths. All right. I wonder how long it'll take to figure this one out. Okay, so now we found that there are 314 where the text is actually not available, but that's fine because 314 out of 368, 171 is totally an acceptable number. If those don't work, then we just move on. Um, However, for this longest one, let's see. I guess I don't know why this one's taking so long. The shortest one like was so fast, right? Um, oh, probably because I knew what I plugged in the actual number. Now it's actually trying to calculate. That's my fault. I mean, it's not great that this is technically hard coded, and that's gonna make this thing take longer. But you know, we didn't need a. Let me interrupt the kernel. Maybe it'll be faster this way. Yeah, there we go. Because we already knew the answer. So this is the that's cool. So we got. I already know that I'm gonna have to flag this as a keyword because it's an abbreviation for director of nursing. So that is a thing that we can do in Spacey. Have a named entity, add to our named entity recognizer. I'm a little confused because I thought I introduced something that would kind of get rid of these dots and these periods. Really not necessary if they're ending a sentence. So that's kind of annoying. Now why is okay? There's like a lot of stuff going on in the longest report. Um, okay, so this is the part that takes a while, and I don't know. Maybe I will uh, end the stream while this goes because it takes so long. But if I do a demonstration of like just give me the first two elements, I'm going to process these tokens. So what I've done is I have this text, this total text, sorry, tokenized total text. I've removed all the things that only appear once. And then what I'm now doing is sending this whole corpora into this NLP pipeline provided by Spacey, where I want it to lematize, and I also wanted to remove stop words. So it is removing anything that's a pronoun because it's probably not necessary. And then it's removing the stop words that are already existing in the Spacey stop words dictionary, not Python dictionary type. So I am having it go through that. Oh, is it done? It is done. Okay, so it's gone through. In this pipeline, I've decided to only keep the text. I think I'm actually going to change that. And let's see what it looks like without it. So let's just say token. Yeah, let's just put the token in. So we will redo this. But you can see like this is a lot, right? There's a lot of tokens in each thing. So we'll do this again. Yeah. So, so that was quite fast, but why did it? Oh, I know why. Because I didn't update the pipe. Yeah. Okay. So we're gonna have to restart the kernel. All right. Well, I've already explained this part, so if y'all don't mind, then I am just going to do a kernel restart and then run everything again. What I will do though is kind of filter this out. So print len shortest, just to have that as a reference. I'm going to delete this cell as well as this one. And then I don't think I need to print longest. Let's see, how can we I think that's fine. So we will now, you know what? I will say for this, we actually just want to see the first one because otherwise it's too much. Restart and run all cells. So we'll just let this go. So now I'm doing restart and run all cells because like I already like walked through and explained what's going on cell by cell. So don't need to go through and just shift to enter everything because that is just kind of a waste of time. So it is now working through exactly the same thing that we already talked about. So it's going through importing the CSV into a pandas data frame. Actually, I just my brother asked me yesterday, like, why do I pronounce it pandas instead of pandas? Since I basically say pandas instead of pandas, and I honestly don't know why. Like, I've heard people basically just say pandas all the time, so it just got stuck. So I'm now like consciously trying to make it like, I thought I heard the Databricks people call koalas as koalas instead of koalas. So now I'm like, oh man, okay. If I have to go over habit, so I'm just gonna try to start calling it pandas. Yeah, so we've got a pandas data frame and it's still working through. Yeah, so where are we in execution? We are going through and tokenizing everything. And this part was pretty time consuming. So yeah, the other things like I technically already have this in GitHub. So I am writing like all this stuff. I've got a login.json, which I will not show because it connects to our private database, even though it's not working. That's in my secrets. I've got a .gitignore that ignores this data, as well as the secrets folder to not put that on GitHub. This is technically on public.github.com. It is a private repo, so I can't, because I don't think I can share it with anyone, even though it is public data. However, the goal is that like I should just be able to get this working with the database connection. So yeah, I've listed like all the places that like people internal to our group can actually access and keep up with all the stuff. I'm realizing now like I have to get rid of some of these things because they're actually not accurate. Oh wait, yeah they are. Cool. Okay, so I can save these. Yeah, so let's save this. So we're gonna cd into repos, form 2567 NLP, conda activate 2567 NLP. So let's look at our git status. So all these things, I'm actually on a different branch now, so I can check out and this is compiled Excel EDA, because that's actually what we're doing with this branch. So we're going to git add readme.id, git add notebooks, the folder, because I modified 2 notebooks. And yeah, so probably while this is running, I'm going to, once this is done running, I'll save this notebook and then commit it. But yeah, this has basically been my past 2 work days, I think, and also working with like tech support to try to actually get me access to the database. Right now, trying to do as much as I can in terms of like this NLP pipeline, so that like when I actually get the database access, I can just change a couple of references, hopefully, knock on wood, just change a couple of references and just send it through this pipeline and everything should work. So that's the hope. Let's see how it sticks to that, but gotta be positive. Finally getting data, gotta hope that everything works out okay, yeah. So let me see what else is going on. I'm gonna look in my Discord and see how things are going. Yeah. In the future in these streams, oh, I guess like big things for me. I am moving soon. Staying in the same area, but I am moving. And oh, I forgot. I wanted to get an under desk treadmill, um, because a lot of my stuff, a lot of my day is just sitting here, and it'd be nice if, like, in passive meetings, I can just like go for a little walk while I'm listening to the meeting, or like walk slowly while I'm trying to code. And honestly, like even on these streams, props to the people who can stream for like longer than an hour. Um, I'm barely hitting an hour now, and I'm like, I need to get up and do something. My watch is complaining that I haven't moved. It'd be really nice for me if I like, took a little break and went for a walk, or even if it was like, hey, I'm just gonna go for a walk right now on while we're talking about stuff. Um, so yeah, like honestly, right now, walking and talking sounds great, because I can't do anything while the kernel's trying to do this. Not even tokenization, just like uh, restructuring of the text. Um, I'm even tempted to not have this like frequency thing in here. Like, I think it's actually for what, let me see, for what I'm trying to do as like a proof of concept so far. Like, I actually think this is kind of unnecessary. So I might just remove this. And I know like this is really slow, right? Because it's like going through everything multiple times. Um, yeah, actually, why don't I interrupt the kernel, and I'm going to comment this stuff out and then try it again. So let's comment that out, and then here we're just going to put texts. I feel like I should replace text with like corpora, but corpora is actually something that's used in Spacey Jensen. So I don't want to like reuse some vocabulary because it would just cause some problems. So we're gonna have to shift enter all of these, and hopefully this will be a lot faster. But one of the things I wanted to show off up top is something I think is really cool and is not actually built into earlier versions of Python. This thing. So I believe starting in Python 3.6 or 3.7, I actually wrote a blog post about this. Python started introducing static typing. And like, I don't know. I think it's really cool because I've run into issues where you get something and it is not what you expected it to be. And I think the major feature of this is that you can explicitly state what you're trying to get as an input, and then explicitly state the type that will go out as an output for each function. And it seems really common sense, but you would be surprised at how many things like they just don't work this way. So I think, let me try to find it. My blog article about this was like pretty kind of funny. Because I was trying to make like a card classifier. How would I describe it? Let me find this article. Oh, actually, why don't I will put this in chat. So if you've ever been curious about some of my previous writings, I did have a Medium. I haven't done anything with it recently. Like, one of my bigger articles was like how to get Docker working on Windows 10, and like this was before Windows Subsystem for Linux 2 came out. So like now it's just old. And now today, Microsoft announced Windows 11 is coming. So yeah, uh, here we go. So this is something I wrote about the benefits of static typing versus Python's default dynamic typing. Um, and I honestly think it's like really cool because like even though it's extra work, like having to explicitly write like import typing, um, and then like explicitly state like I am expecting in this case a list going in and a list going out. Um, like the example I had was where is it? Say you're dealing with a deck of cards. So actually, we'll put this over here so you get like a preview as to what I'm talking about. Oh, no, don't load. Don't do that. There we go. Cool. Okay. So I said like, okay, well, think about a deck of cards. There's 52 cards. There's 4 suits. There's 13 members of each suit. So they go from ace all the way up to king, or 2 all the way up to ace. Doesn't really matter. What we do care about is that there are actually like 4 like face cards. So like jack, queen, king. I guess you can count ace. But some of these things, like if you're playing blackjack, I believe 10 joker, queen, and king all count as 10 points. I haven't played in a while. And then ace can count as 11, right? 11 or 1. So the thing is, like, if you're trying to pick a card, I wrote this, like, dumb little function game. It's like, you want to pick a card from a hand. And there's 13 cards and they're all 1 suit. So you just want to guess a card between, like, ace and king. So in this particular instance, I said the list is composed of a bunch of strings. However, when I asked the user for an input, I said, okay, cool. If you put jack, queen, king, or a, it's really obvious that you're dealing with a string. Also, this article is full of puns, just FYI. However, if you actually play this game, I didn't realize, but like the input taken in the command was actually treated as a string. So even though I put an integer, it got like somehow converted into a string. So this was actually one of the things that like I thought was a good example of where static typing could help, because I assumed that the input would generally just be an integer because there's 2, 3, 4, 5, 6, 7, 8 all the way up to 10. And very rarely, I guess 25% of the time, it is actually a string. So like, I don't know which one, like if I'd put ace, it would have been fine. But if I'd put 2, like I didn't know that it would just treat that 2 as a string instead of an integer. So now that I've written this function, I know that like it's actually going to be a string. So that like having that explicitly there like actually really helped and would have helped me like figure out what was going on with this like game. Now, where this can actually be a bigger problem shows up all the time lately, and actually shows up in this data set. I'm going to close this. If you go back, it's still processing. If you go back, you remember that like we have this zip code, right? The zip code category, and also even in this deficiency tag here. So if in this case we had let the pandas read CSV function just work, it would actually just process zip code and deficiency tag as integers. And this is a big problem, right? Because like zip codes are 5 digits and there's a leading 0. So in this case, like we would just have a 4-digit zip code and then have to figure out how to fix that later. But they're totally fine in the CSV. Same with this deficiency tag is actually 4 things, 4 characters. There we go. And like we just want to make sure that it preserves that structure. Other things are like this complaint, standard, infection control. Honestly, these are probably booleans, right? And they just got marked as like ones or zeros, which is kind of fine. I think booleans in Python are treated as integer zero and integer one. Um, so that I don't think that's going to take a huge performance hit, but like it's still nice to know that like, everything is preserved structure wise and it makes sense. Also, this facility ID, having now worked with this data a lot, this is always 6 digits or 6 characters, and they start at zero and then go all the way up to six something. But like they start at zero, so there's a bunch of them that are just like 0, 7, 5. So if we let this go as a integer, like this is going to be a problem because we have 5-digit things and like those don't show up in our databases. Um, yeah. Okay. So I think this is finished. Yes. Cool. 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 Um, that's weird. Uh, this didn't preserve the um, token value from NLP, because normally you can get this like named entity identifier. Um, that's really strange. Yeah. So, I wanted the lemmatization and then to just get back the thing. I wonder if maybe lemmatizing. You know what? I wouldn't be surprised if lemmatizing destroys this because it doesn't really need this. And it could also be this like after named entity recognizer. Um, hmm. um, yeah. Okay, cool. So I've got some cool work to do to basically parse through the, what's it called? Um, Documentation, and just to better understand how this is working, because I actually want to see what Spacey thinks these words actually are, Um, care. I think these are lemmatized. Nurse, aide, assistant, ambulation, provide, person. Like, these aren't sentences, right? Um, why is left-sided? Yeah, I think these are lemmatized bases now. And I'm not sure why there's an empty string here. Um, hmm. Oh, maybe that's the period? Okay. But then if it's a punctuation, it shouldn't have been kept. That's interesting. Hmm. But yeah, I mean, I don't see alternate forms of verbs. So I do wonder if maybe the limitization's like not the right thing that you want to do if you want to actually see the structure. So yeah, okay, cool. All good stuff to learn. And I don't know, I'm having fun. I think I will take a break now though, and at least like stretch my legs a little bit. And then after that, I'll probably come back and then we'll just take a look at the what's it called, documentation, to try to figure out how to process this. All right, so I'll be right back. Okay, so we are back. And right now we're going to go through a little bit of the documentation to figure out this problem right here. We, or at least I, don't know why it is not actually displaying the whole token, right? Like, I want to actually see the tokens for right now, just to see what it thinks. By it, I mean Spacey, what it thinks each of these is. So could be that maybe we don't want to actually do the lemmatization, right? We just want to do just the tokenizing and the what's it called? Part of speech tagging. So for that, we're going to open up the Spacey documentation, spacey.io, and we want to see talk to Vec. Interesting. So we want to so we want to load this correctly. So loaded court, and we don't want to disable anything. That's interesting. Yeah, I think I know what it is. I think it's me putting this lematizer. So let's see. We put it after the named entity recognition. So how can we just get the... Why don't we comment this out first? See what happens. And then we're gonna have to run this all over again. Yeah, that's weird. I think I just realized, like, I'm sending their stop words twice. Okay, let's try this again. In the meantime, let's, probably the easiest thing is to just pretend like we're just starting from the very beginning. So if we do, yeah, I mean, like, this is almost exactly what we want, right? Like, it's just like, give me the text, the lemma, the part of speech, the tag. Interesting. Okay, so let's say for token in doc. Actually, I can literally just print this or copy this over. Oh, I think I messed that up. Because in this case, the doc is... yeah, I messed that up. This is going to be wrong. It's going to throw an error, and it's because, like, I'm now technically having to go through a list. So what I'd rather do is for... let's see, docs 0. But when it crashes, we will get there. Basically, it's going to take a really long time to get back into through here. That was much faster than I expected, but that's just Pandas play. So yeah. Um, what else can we do while this is running? Yeah, like it would be interesting to see these things. I don't need the shape. That was bad. Let's actually just get rid of that because it's super not necessary. And then, yeah, when that crashes, we'll just go. Cool. Oh, actually, wow, that was way faster than I expected. Okay, did this error out? Yes, it did. Okay, cool. So let's try this again. That's weird. Um, why is this... Why is this not working? Okay, what's type for token in docs? Print type token list. Okay, so that's why it's not print token 02. Okay. So it's a list of type oops, that's my bad. Let's see. How can we... So this isn't a token. That's interesting. It's almost like for docs, print for token in doc, print type token. Okay. That was my fault. Okay, cool. Okay, that's actually what we want, right? So we want for docs in doc, for doc and docs, and then okay, cool. All right. Oof, we gotta prettify this. How can we? Oh, it's pprint. Damn. Okay. So this works at least. Maybe I can actually store this in it would be better if I could format this as a sorry, I didn't realize chat went down. better if I could format this as a table and then actually have everything all nice and neat. Because obviously I can't, it is a little hard to read this. But at least we can see this. I mean, it's pretty cool. Can even see the lemma. So the lemmatization is working. So before that was actually just, it was actually doing the lemmas. I don't know if it really needs the part of speech tag after all. But we could use the name entity recognition because some of these things are going to be helpful to have as like Dom, or Don. I think it was Don, Director of Nursing. Interesting. Okay, well, now that we have this part working okay, I think we still want to do the lemma. And we also still want to try to do a, what's it called? LDA. We have to put it through Gensim, which I think Gensim would prefer to have the lemmas instead. Okay. Yeah. All right. So this is the part where this is going to take forever. Okay. So this works. It's interesting. What we want to do is basically convert the entire set of documents into a corpora. So what we're going to do is basically just, I don't know why here they could have, honestly, this would have been better to do a, what's it called? List comprehension, kind of like what I did up top. So we now have this here. I could just remove this. I'll just call this first two docs. Just add this in here. So when I do shift enter later or run all cells, this actually works. And then what we're going to do is basically take this cell and get rid of that 0 to 2 and then see what happens. I feel like this is the fun part where basically just try things until it breaks and then see what happens. Chat is down. I'm sorry about that. I don't know what is going on. Maybe if I refresh the page, could just be not working. Okay, so anyway, I'm going to process all of the docs in Spacey and then make an overall document, and then I'm going to put that through into a corpora. So I'm pretty excited. This means that we're like actually pretty close to putting it in Gensim. So let's say after this, we're going to do this. And then we're going to do this. Turn this into that. And then look at this. We're just going to copy this over and boom, corpus, words, num topics. I mean, this we don't know. And, we're just going to give this a try, Then after, I'm going to copy the same thing. I don't know why this is now a picture. So we're going to do, where's the cursor? Pprint. LDA model dot print topics. LDA model dot print topics. Let's say numwords equals 10, just like in the demo. Yeah, let's just do that. Yeah, okay. So I don't know if it is better to use the lemmas or the regular words. Honestly, it's probably better to use the lemmas. So that is probably a thing I'm going to change after. I could just make a could actually make a new set that is new lists of lists where all it is the lemmas instead of the actual text. That's something I can add to my to-do list because that would actually be helpful. So let's see. I don't know why this is doing this as an output. It's really weird. Okay. Wonder if I can just take and let's see. So I've got this. Oh. So, I can do another list comprehension, I think. So for token in doc, actually start writing this down. This would be lemma docs equals this one might be easier to write as docs equals, I hate doing that, making that empty list and then adding to it. So what I want to do is for doc in for text in texts for token in text. Oh, this doesn't sound right. Okay. So I've got, oops. works. Let's see. And then for each thing, token dot lemma for token in doc. Right? Yeah, okay, we'll try that. Yeah, let's see how, let's actually open Activity Monitor, see how hammered this thing is getting. Oh, and it is in a different monitor. So let's take a look. Bring that over here. I haven't maxed out the memory yet, so that's good. Well, I guess all we can do is let this run. Yeah. And I'm going to check if maybe Restream is down. Is Restream down? It's kind of weird because it looks like I'm online. And I'm streaming to my desktop, which is streaming out, so that seems okay. I mean, this loaded, so my internet's not down, right? Okay, cool. I'm going to be right back and check some configs. Okay, so I I don't know what's going on. My internet looks like it is totally down. It's very strange. All my VPNs can't connect, and I'm not sure what's happening. So I'm gonna end the stream, and I hope I'm not in trouble because again, I am working with public data. Um, and I hope it's not just like my computer just getting like really overloaded and trying to process this text. I have no idea. I'm super confused. But yeah, okay. So hopefully, I will see all of you again soon. And that, I don't know, I hope to actually make some big progress on this. I'm like pretty excited to work on this. So yeah, okay. So yeah, my contact information, Twitch is there, YouTube's there, Instagram's there. My Medium was posted in the chat. I can't put anything else in chat anymore because my work computer is not connecting to the internet. Yeah, cool. I hope to see all of you soon, and take care. Have a nice day. All right, see ya.